Hi, I'm Bill Snodgrass. Welcome to this episode of The World Around Us. In this episode, we're going to do a virtual lab, and we're going to talk about the setup and the procedures, how you conduct the lab, and also we're going to talk about the data that's collected and how to use that data, and then we'll talk a little bit about the analysis. So let's get started with, there is a lab template, and the link to the lab template is down in the description of the video, so grab that and follow along. All right, let's look at the setup of this lab. It's really a very simple setup, just some meter sticks and some tape and some other few things. But it does require using two smartphones, one as a timer and one as a video recorder. Or you could use a regular camera and a stopwatch, whatever, but pretty much assuming that if you're watching this video, you probably have access to, smartphones. So here's the setup. The physics behind this is fairly simple. Ultimately you want to do is graph the velocity of the ball as it travels through three 10-centimeter intervals. So we'll have capturing time, initial time, final time, initial time, and we'll use that to calculate an average velocity. It will slow down a little bit because of friction and stuff like that, but it'll give us a decent graph and some things to talk about. The setup is very simple. What I have is 4 meter sticks. I have 4 meter sticks and a ruler. The purpose of the ruler is a spacer to space out the 2 meter sticks. So the meter sticks are uniformly spaced, whatever distance this is. I didn't even measure, it's just a ruler. This is a ball I found. It's fairly smooth and it's not terribly heavy. The way we're going to do this is we're going to roll the ball past the increments on the other meter stick. So this is 2 meter sticks taped into a triangle, and I can adjust it to wherever I want it on the track. Over here at the end of the track is a bin to catch the ball so it doesn't go rolling across the lab. This is a very fancy phone holding device. It is a box with a screwdriver stuck in it. It's going to hold the phone up with the timer on it. The timer is more or less central to the intervals that we're going to measure. We're going to measure between 10 and 20, 20 and 30, 30 and 40. This is a second camera phone, and it is zoomed in so that it is showing the 3 intervals of interest, the intervals of 10 to 40. It also has in it the stopwatch. The stopwatch is also in it. So this is what that's going to look like. So the ball is going to roll past the 10, the 20, the 30, the 40, and it's going to go off. We're going to capture that. All right, so that's how this is set up. All right, so I'm going to actually capture. I'm going to capture a little bit here, and this will go. This footage will go to the end of the video. So you can, if you want to use this data for your lab report. So here goes. I'm turning on my camera. I want to roll the ball enough that the velocity is high enough that the little bit of deceleration is negligible, but I don't want it to go so fast that it exceeds the capacity of my timing device. So I'm going to hit start here. I've already started that, and I'm going to roll the ball. And I'm going to roll it again. We'll collect another sample. So I'm going to roll a little bit faster. And one more try in case we want to do 3 trials of data and average them. So for the purposes of the data collection, what we want to do is we're going to graph that motion. What was the initial time here? How long did it take to get to here? How long? And that total elapsed time and then the total distance travel. We'll graph that. We should see something that is noteworthy. All right, that's it. Let's talk about the data collection. All right, that's how we set it up. It's pretty simple. Some meter sticks, some tape. And then the procedures, we're going to roll the ball past the meter stick. We're going to collect those pieces of those intervals. So as the ball passes the 10 centimeter mark, and then as it gets to the 20 centimeter mark, that's one time interval. One thing that's very important when you're rolling the ball and timing it is you want to capture the same point of the ball as it crosses each of the intervals. So you don't want to use like the top of the ball for the first interval mark and the front of the ball. You want to use the front of the ball for the whole thing. So when the front of the ball reaches the 10, that's going to be what we're going to call interval 1 initial time, T sub I. And so what you're seeing right now is the from the lab template. So the interval 1 time is going to begin when the ball hits the 10 mark, and when it ends when the ball hits the 20 mark. The interval 2 time begins when the ball hits the 20 and gets to the 30, and then the interval 3 is from 30 to 40. All right, so you're going to collect those time readings. You're going to need 4 time readings. Initial when it gets to the 10, then when it gets to the 20, when it gets to the 30, and when it gets to the 40. And we're going to use those 4 time intervals. The calculation then becomes the interval 1 time is when it gets to the 10, when it gets to the 20 minus the 10. The interval 2 time is from the 30 to the 20, and the interval 3 time is from the 40 to the 30, and that's your time intervals. Now, because of the way we set the lab up, the displacement for each interval is going to be 10 centimeters. We set it up so we have the same displacement. This is going to allow our graph, hopefully to reveal something to us. All right, so we're going to graph this out, and there's a table that you need to complete. The lab template makes it pretty clear what you need to do in the table. So you're going to grab the data. Also, my trial data for this experiment is at the end. So if you're doing the lab completely virtually, you can go to the end of the video and grab I did 3 trials. You can pick one of them, or you can use them all and average them. So if you do 3 trials, then you do need to fill out the table for each of them, and then do the average table and use that for your graph. So the graph, the table that is going to call for calculating some things. When we graph it, we want to start with a 0 displacement and a 0 elapsed time. So then the first displacement would be 10, and whatever the elapsed calculated time is, and then the next displacement, it'll be a total displacement of 20 and a total elapsed time of whatever the 2 intervals are, and then finally the total displacement will be 30, and the total elapsed time will be the sum of all the pieces. And that's worked out in the lab template pretty clearly. Analysis-wise, this is where hopefully if you had a high enough velocity and a low enough deceleration, you're going to get a fairly consistent velocity across the intervals. It should go down because we know there is some friction, but hopefully it won't go down so much that the outcome is lost to the friction, to the air. What is slope? Well, slope is the rise over the run. And if rise is the distance, the displacement, and the run is the time, then our velocity formula is distance equals velocity times time. So if we rearrange that, we have distance divided by time is velocity. Now, if distance is the rise and time is the run, then distance divided by time is rise over run. The slope of the line should be the velocity that we had on the ball. So for each of those intervals, the slope of the line is going to change slightly. That interval velocity, that slope of the line from those 2 points is the velocity over that range. And that's kind of the thing that we walk away from this with, is that the slope and the velocity should be the same, or they are the same, and we should see that in our graph fairly readily. So that's it. All right, so in the conclusion section, you write up your results, in sentences and say, the first interval was this time and this, we calculated velocity over that interval with this and that. And then it does ask you to discuss the reason that the velocity did not stay constant, and that would be the friction of the ball rolling across the track. And then lastly, you get an opportunity to discuss what we just talked about with the rise, the run, the slope, and the velocity, and all that sort of stuff. So it should be a fairly easy lab to set up, fairly easy to conduct, and the results should be not surprising, but satisfying to be able to say, well, look, the math and what we observed in the lab works out and works out the same. So that's it. All right, so that's it for the conclusion. Let's look at the data that I collected, and you can use this and stop the video and read where it goes, frame by frame as you can. Then that will be the sample data. So here comes the sample data, 3 trials, and then after the sample data will be done. All right, so that was your sample data. That was it. 3 trials. You can extract from those the interval times, make your charts and graphs. Maybe you just want to do 1 trial, and that'll be fine too. So that's it. That's it for this episode. Please click the like button, subscribe, all that YouTube stuff. We'll see you in the next episode.